Hi everyone. Some members of the Mechatronics Club at San Diego State University had a few engineering questions, so I'm making a video answering some of them. For context, the questions I'm answering today revolve around the International RoboSub competition held every year where teams from around the world build an underwater vehicle and compete with them in an underwater obstacle course. The RoboSub vehicle needs to be completely autonomous, meaning it needs to think for itself while navigating and manipulating objects in its underwater environment. When I was a student at SDSU, I created the Mechatronics Club and we started competing in this competition. Our first competition was in 2014 where we placed 8th out of 39 teams, and in 2015 we ended up getting first place. Now I could spend hours talking to you about the blood, sweat, and tears it took to get in first place, or how I thought we won because we had a better team that year and not necessarily a better vehicle than the other competitors. But that's content for another video. For this video, I'm going to answer some questions. Also, I happen to be in the middle of a mini server rack build behind me, and watching me assemble that is probably more interesting than watching my face. So let's hop on over there and I'll answer a few questions. Okay, so by the way, this is my mini server rack. I'm using it to keep single board computers. At work, I often work with a lot of single board computers. So this is super helpful for keeping everything organized as opposed to just splayed across my desk. Okay, so Kai from Mechatronics asks, do you think it's worth the development time and effort trying to use vision-based dead reckoning? For those that don't know, the competition has the very first obstacle that you need to do is go through a validation gate. This validation gate is at a certain depth underneath the water. It's usually the first obstacle every single year. All the obstacles change every year, but the first obstacle that they've maintained for many years has been the underwater validation gate. And you need to go a certain depth underneath the gate and then just drive in a straight line. Honestly, how we ended up tackling that was in my years in 2014 and 15, we just went to a certain depth and we didn't even use vision processing to go through the validation gate. Because we had a navigation system, we were using a Doppler velocity log, and we were able to basically track position with respect to a relative starting point. So that was enough for us to just make it through the validation gate. Now, that doesn't answer your question. You're asking just using dead reckoning, using vision. I think, like any good answer, it depends. It depends on where you're at as a team, what your goals are as a team, what generation of vehicle are you on? Like, is this a vehicle that you guys have been using for a while? All that sort of factors into what you want, what strategy that you're going to use. Now, I'll say most teams that just use, at least from my experience, from what I've seen at the competition, most teams that use vision-based dead reckoning for the majority of their system don't usually make it very far. There are teams that try to do that, and usually they'll have a hard time just making it through the validation gate. So I think it's really worth investing the time to try to get other sort of sensors in your system. So, for example, pressure transducers that tell depth. I think that's very important. Orientation is also a must. So, like, for example, an inertial measurement unit like an IMU. These are things that you have to have as a feedback system. I think vision processing can help you some of the way for manipulation tasks, but I don't think that should be the sole mechanism for your whole entire navigation system. Yeah. Okay, Kai also asks, if you were to do the vision aspect of the competition without an object detection convolutional neural network, how would you go about it? Well, it's pretty easy because we didn't use that in 2014, 2015 at all. What we primarily used was OpenCV for the vision system. We primarily used OpenCV with CamShift. That's how we did a large majority of the obstacles in 2015. And this wasn't like, it was very, very rudimentary. It was one of those things where it's just like, let's just get it working, and then we'll figure it out later. And we always kind of wanted to make this a little bit more advanced, and our generation just never sort of got around to it because cam shifting worked well enough. There's so many other things that we needed to resolve at the time. But if you want to try to start from scratch, maybe that's a good place to start from. Oh yeah, and also if you do cam shifting, one of the interesting things was we didn't use stereo vision. We were using a mono camera in the front. So a question that commonly came up is like, how are you approximating depth with the obstacles that you had to interface with? Well, beforehand we know the width and height of the objects that we're interacting with in underwater, like shooting torpedoes through holes and stuff like that. And so we were able to approximate how far away we were from the object because we knew the size of the object. And if you know the size of the object, you can correlate them to your pixel width and height. So if cam shifting is making an ellipse around a specific object and it's encapsulating a certain amount of pixels in the width and height, you can sort of make a rough guess about how far away you are from that object. Now that assumes that you have pretty good lock on your minimum hue, saturation, and value. If you don't, it can go very wrong, but that's why you have a feedback system. Like other things, like generally what area the obstacle is in, and you can sort of use that as your source of truth. Also, somewhat related, we were using triple modular redundancy on a lot of the sensors. So for example, the AHARS, or IMU, people call them IMU, it's we use an AHARS, which is a little different and it has Kalman filtering built in. An AHARS is an attitude heading reference system. And we had 3 of them, and we ended up taking the median value of all 3. And we did this with other sensors too. We did this with 3 pressure transducers as well. So we were able to use that to sort of get a better sense of where we were. Yeah, none of this is neural networks. I almost think if you try to, again, this is my opinion, but I feel like if you try to go too deep into neural networks, you could be shooting yourself in the foot because you might be adding complexity that is not really necessary. Do I think there's a place for neural networks in this competition? Yeah, I do. I think it's totally possible to do very well in the competition without using technology like that. But, if this is something that the team is interested in doing, like if you have members in the software team and they're very passionate about using neural networks, I say go for it, because I think creativity and passion drives innovation. So that's something that you kind of got to play to your strengths and the amount of people that you have on the team. So, okay, next question. Kai, also from Mechatronics, asks, what is the best method you have found to pass on knowledge, not limited to college experience? Oh, this is a really tough one. We sort of, at least in Mechatronics, we always struggled with this. One method that we did to sort of combat this, like pass on knowledge as generations graduate and move on, is we made a student handbook. Now, if you don't know, any Mechatronics members, if you don't know what the student handbook is, then I guess we didn't really do a good job propagating that. But regardless, we still tried. Looking back at it, are there things that I think that we could have done better? Yeah. Like I would have probably open sourced all the software, even though it's a competition, I think I would have open sourced all the software for RoboSub, um, because there's been uh, changes of version control in the past, of who owned what server, and who's hosting the code. And I think some stuff has been lost over the years because of that. But if we just went with an open source solution, um, I think it would have probably been better maintained. And also, I think alumni in the future could have um, came back to the uh, source code repository and maybe help contribute or have code reviews, as opposed to keeping it on lockdown and proprietary. So that's probably something that I would have changed, at least as far as the code goes. But yeah, I still sort of struggle with what the best way is to pass on information to future generations. Um, it's something we thought about a lot, and this is not just a mechatronics SDSU problem. Talking to other teams at the competition, they were also having this issue of passing on information to the next generation. One of the things that we had in the handbook, though, that I sort of I really agree with, which is, and we got this after like surveying a lot of other teams and talking about this, was I don't think it makes a lot of sense to try to continuously mature a RoboSub vehicle for many, many, many years. Like, for example, like take our 2015 vehicle that we won with. We could have just kept using that over and over and over and over and over again. But in the handbook, what we wrote was I believe it was every 2 years, we scrap the vehicle and start new. And there's a really good reason for that, I believe. It's to make sure that future generations have the ability to make their own vehicle and to feel like they're contributing to something, as opposed to just carrying on a legacy from previous teams. And that usually keeps them more engaged with the project. No one wants to continue a vehicle that a previous team has just been keeping for many years. And you also learn a lot more by working on it yourself. And so that's why I said, like, every 2 years, like, we scrap the vehicle and start from scratch. Next question. Kai also asks, what are some ways to keep members engaged through the semester when they get busy? Not necessarily contributing, but at least kept up to date and participating. Yeah, this is also a really good question. I think that it's not uncommon to start off with 50, 60, maybe even 70, 80 people in the club during the start of a semester, and then just radically see that decline as school picks up. That was something that was very common, unfortunately. But people get busy and they have other priorities. I will say, and I'm probably being biased here, talking to many recruiters from companies, you want something that's going to set you apart. And saying, "Oh, I completed a engineering degree," doesn't really cut it. I mean, maybe you'll get lucky, but there's a lot of people that have engineering degrees that are trying to get like the same job that you're applying for, right? So I think it behooves you to participate in extracurricular activities like mechatronics. If nothing more, to have almost like a internship style learning experience so that you can be picked up at the company that you want to be picked up at. And I've told other members this, where they can totally put mechatronics as like quote-unquote internship on their resume. I think it's deserving of at least that, because I've had other internships in my life where I know that I learned a lot more in mechatronics than I have in any other internship. So I think having some sort of blog posting on the website, not just Discord, that might be valuable. I don't know how many people look at the website, but having blog posts about where you're currently at, I personally would enjoy to see something like that. And not everybody's on the Discord, so that might be a good outlet to show updates. But yeah, I think people are going to, it's just going to happen. People are going to get busy with school, and then you're going to have a massive drop off. I think one year we had like 100 people apply, and then only 20 people go to the competition. So yeah, it happens. If you find a good way or a good answer for that, I'd be interested in knowing it. But yeah, sorry, don't really have the best of answer for that. But anyways, those are all the questions. So mechatronics members, if you found this useful, continue asking questions, and I'll keep answering in a format similar to this one if you find it useful. And those of you that are not mechatronics members, but if you still want to ask questions, feel free to do so. Comment on the video, and I might answer it in the next Q&A session. So, thank you. That's all for now.